Welcome to the future, where we're about to turn fiction into reality. Today, I'll guide you through the exhilarating journey of crafting your very own flying car. Strap in as we delve into the mechanics, the technology, and the sheer ingenuity required to bring this dream to life. Today, we're diving into a crucial topic for anyone looking to take control: how to make flying car. So before we get started, make sure to hit the like button. Also subscribe to my channel. Creating a flying car is a fascinating endeavor that blends the realms of automotive engineering and aeronautics, pushing the boundaries of transportation innovation. In this comprehensive exploration, we will delve deep into the intricacies of designing, building, and operating a flying car, covering various aspects such as aerodynamics, propulsion systems, safety considerations, regulatory challenges, technological advancements, and potential societal impacts. Design considerations. A flying car's design must strike a delicate balance between aerodynamic efficiency, structural integrity, and practicality for both ground and air operations. Aerodynamics. The vehicle's shape and structure must be optimized to minimize drag and maximize lift during flight. Streamlined contours, wing configurations, and control surfaces play crucial roles in achieving aerodynamic efficiency. Structural integrity. Given the dynamic forces experienced during flight, the vehicle's construction must be robust yet lightweight. Advanced materials like carbon fiber composites offer strength without excessive weight, enhancing structural integrity. Transition mechanism. One of the most challenging aspects of flying car design is developing a seamless transition mechanism between driving and flying modes. This often involves retractable wings, adjustable propulsion systems, and automated control mechanisms to facilitate smooth transitions. Stability and control. Maintaining stability and control during flight is paramount for safety. Sophisticated flight control systems, including fly-by-wire technology and gyroscopic stabilization, ensure precise maneuverability and propulsion systems. The propulsion system is the heart of any flying car, providing the necessary power for both ground and air propulsion. Vertical takeoff and landing. Many flying car concepts utilize vertical takeoff and landing technology, enabling the vehicle to take off and land vertically without the need for a runway. Electric motors, jet engines, or turbine propulsion systems may be employed for vertical thrust. Power source. Efficient power sources are essential for sustaining flight and powering ground operations. Electric batteries, hydrogen fuel cells, or hybrid systems combining electric and combustion engines offer viable options for propulsion. Hybrid systems. Hybrid propulsion systems that combine multiple power sources can optimize performance, range, and energy efficiency. Electric motors may be used for ground travel, while combustion engines or turbines provide additional thrust for flight. Safety measures. Ensuring the safety of passengers and bystanders is paramount in the development and operation of flying cars. Redundant systems. To mitigate the risks associated with component failure, flying cars incorporate redundant systems for propulsion, flight control, and critical subsystems. Redundancy enhances reliability and fault tolerance, minimizing the likelihood of catastrophic failures. Collision avoidance. Advanced sensor suites, including radar, LiDAR, and optical cameras, enable real-time detection of obstacles and potential collision threats. AI algorithms process sensor data to implement proactive collision avoidance strategies, ensuring safe navigation in congested airspace. Emergency procedures. Protocols for emergency situations, such as system malfunctions, power loss, or adverse weather conditions, are integral to flying car safety. Emergency landing procedures, onboard safety systems, and passenger evacuation plans must be meticulously designed and implemented. Regulatory challenges. Integrating flying cars into existing airspace infrastructure poses significant regulatory challenges that must be addressed to ensure safe and responsible operation. Certification. Flying cars must undergo rigorous certification processes established by aviation authorities to validate their airworthiness and compliance with safety standards. Certification requirements encompass design validation, performance testing, and operational assessments to mitigate risks associated with flight operations. Airspace integration. Coordinating flying car operations within existing airspace frameworks requires collaboration between regulatory agencies, aviation stakeholders, and urban planners. Specialized airspace corridors, designated landing zones, and air traffic management protocols may be implemented to facilitate safe and efficient integration into urban environments. Licensing and training. Pilots or operators of flying cars must undergo specialized training and obtain appropriate licenses to operate these vehicles safely. Training programs encompass flight proficiency, emergency procedures, navigation skills, and regulatory compliance to ensure competent and responsible operation of flying cars. Technological advancements. Advancements in technology play a pivotal role in driving the evolution of flying cars, enabling breakthroughs in performance, efficiency, and safety. Autonomous flight. The development of autonomous flight capabilities revolutionizes flying car operations by reducing reliance on human piloting skills and enhancing operational safety. AI-driven flight control systems enable autonomous takeoff, navigation, and landing, opening up possibilities for unmanned aerial mobility. Electric propulsion. Electric propulsion systems offer numerous advantages over traditional combustion engines, including lower emissions, reduced noise pollution, and enhanced energy efficiency. Lithium-ion batteries, electric motors, and power electronics form the backbone of electric propulsion architectures, enabling sustainable and eco-friendly flying car operations. Materials innovation. Lightweight materials, such as carbon fiber composites, titanium alloys, and advanced polymers, revolutionize flying car design by offering high strength-to-weight ratios and structural integrity. Materials innovation enhances performance, efficiency, and durability while reducing overall vehicle weight and aerodynamic drag. The development of flying cars represents a paradigm shift in transportation innovation, promising to revolutionize urban mobility, enhance connectivity, and unlock new opportunities for economic growth and societal advancement. While significant challenges lie ahead, from technical feasibility to regulatory compliance, the transformative potential of flying cars is undeniable, paving the way for a future where the skies are no longer the limit. What do you think of our video? Let me know in the comments section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.